I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 5th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like the video, give us a thumbs up, subscribe, get automatic notifications when the videos are posted, typically on Sunday evenings. Ring the bell, that'll ensure you get the subscription. Also, I want to take a minute to thank Paul Tornillo. He's the first person that has given us a special thanks. If you look below, there's a little heart with a $sign in it. You can make a donation to Stormsurf. That helps our operation. We really appreciate it. And Paul was the first person to make a donation. So thank you very much. All right, let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see a gale off the North California, South Oregon coast, still producing 18 to 19 foot seas aimed at the coast. Swell from this system is impacting California, but it's pretty raw, pretty jumbled. Otherwise, a little bit of something is trying to organize off Japan with 20-foot seas, but not otherwise a whole lot is going on. Pretty quiet over the North Pacific for the moment. Looking at current conditions for the North California coast, we'll look at the Point Reyes buoy, number 029. 46012 is down, unfortunately, along with a whole host of other buoys in Hawaii and up and down the coast. Not sure exactly what's going on, but unfortunately, it sort of hinders our ability to monitor surf remotely. All right, we're looking at all the energy hitting this buoy from all the way up at 33.3 second period, super long period energy. Yeah, 1/10 of a foot. Most energy somewhere in about the 14-second period range. Another little bump of wind swell about 9 seconds, something like that. Putting it all together, we can tease out the swell. 8.2 feet at 13.5 seconds from the northwest, 300 degrees. That roughly equates to surf at 11.1 feet on the face, double overhead or so, with the wind swell in there at 7.6 feet at 10 seconds. And also, down here we have a graph. It tells you the estimated surf height for the past couple of days. You can see, at least get a hint of whether you missed it or not. Going down to the north end of Southern California, East Santa Barbara buoy, 46053, we see the same pattern, but far smaller. Little bump of energy, some scattered between 14 seconds and 10 seconds, a little bit of wind swell in there. You get the idea. Shadowed for the most part. Primary swell 3 feet at 11.2 seconds from 288 degrees, wrapping in around Point Conception. That's surf about waist high. And then some secondary energy in there too, 1.6 feet at 14 seconds, about thigh to waist high. Going to the south end of Southern California, buoy 191 Point Loma South. Same sort of deal, bit of energy here, sneaking around the Channel Islands a little bit better, with a bump at about 14.3 seconds, with a bunch of wind swell mixed in there too. Primary swell, 2.2 feet at 14.4 seconds. From the west, 268 degrees. That's surf about waist high. That seems about right after checking in the waves. And then secondary wind swell mixed in, 1.6 feet at 10 seconds. And then going out to the Hawaiian Islands, the Waimea Bay buoy, down. Honolulu Bay buoy, down. Puella buoy off of Maui, down. So we're stuck way out in the ocean, northwest Hawaii, number 2 buoy, 511101. You see wind swell from the east, 3.4 feet and around the 10-second range. That's just this one little area, but pure swell is a mixture of everything on either side of the shoulder of the peak. Primary surf or primary swell, 5.5 feet at 9.9 seconds. From the east, 111 degrees. That's surf at about 5.5 feet, but it's not even that big in Hawaii. And then even lesser period wind swell at 4 feet at 6 seconds. Just looking at any potential swell sources, is significant wave height for the North Pacific Ocean, California there, Aleutian Islands, Hawaii down there, Japan, Kurils and Kamchatka here. A little bit of a gale here, something tried to organize in the northwestern Gulf on Wednesday, the 1st of March, with 23, 24-foot seas, building up to about 28 feet, but most of this shadowed relative to North California, too far east for Hawaii. Then a secondary batch of energy pulled in there starting on Friday from a trough that was developing off the U.S. West Coast, producing 18 to 20 foot, and there's some 23-foot seas on Saturday, the 4th of March. And then as we got into Sunday, those seas fell south off of North California, 21, 22 feet, something like that. And that energy is hitting as we speak at this moment. We saw that reflected in the buoys just a second ago. So we're going to try something a little bit new here. It was suggested by one of our viewers and seemed like a reasonable idea. Surf forecast for a couple of locations, the same places that we were looking at to check the surf just a moment ago. Surf height here on the top. This is all on stormsurf.com. Waves theoretically up to 12.9 feet, slowly fading. This goes for a whole week. This is not a 2-week forecast, just a 1-week forecast. You can see the day of the week and the hour in a 24-hour clock down here along the bottom. So today, Sunday, 14, that's about 2 p.m. Local time. You see the swell slowly working its way down into Thursday, and then theoretically peaking up again around 8 or 9 feet, something like that, on late Friday, early Saturday, the 11th of March. But you can also see, and you can see the wind pattern here too. You just look at the arrows. They tell you whether it's west, southwest, northwest, and wind speed. So kind of windy, bumpy, westerly wind conditions. And then as we get into this bit here, you see south winds coming up pretty strong at 30 knots at one point. And then you can also get the details here. Swell height, 10 feet like today, 10 feet at 12 to 13 seconds, that sort of thing. And this bump out here is 10 feet, but 9 seconds. So just all pure wind swell. So you get an idea of what's to come. Mainly declining swell and then a bump of wind swell about 5 days out for Northern California. Doing the same thing for Santa Barbara. Well, pretty small surf you can see in the 1 foot range sort of thing. And then coming up as we get later on 5 days out or so, wind kind of all over the place, pretty strong. Not so bad though, 5 days out. But looking at swell, well, here is probably the best hope, 3 feet at 8 to 9 seconds sort of thing. So pretty quiet. We go down to San Diego, surf height varying between roughly around the 2 foot range, maybe coming up a week from now. Wind, well, you can see for yourself, not horrible, but not great either. Swell height, probably more interested back here, 2 to 2.5 feet at, again, wind swell. So just kind of a mixed bag of stuff, nothing particularly great. But then we go to Oahu, surf real small, but then as we get into Wednesday afternoon, surf coming up theoretically 20 to 24 feet. And I'll take some of this with a grain of salt. This is just pure data right off the models, as raw as you can get. We try to filter out the junk. You know, our manual forecasts, it's a lot different process than this, but it gives you a quick look of what's going on at your local break. You see 20-foot surf, theoretically slowly working its way down. Winds, though pretty strong out of the west at 25 knots or so, slowly fading. So maybe somewhere here in the back of this swell we'll get more reasonable winds, but nothing great. You can see the swell height theoretically 15 feet at one point at 15 or 16 seconds, then fading into the 7 to 8 foot range down to wind swell, basically 11 seconds sort of thing. So Hawaii, though, best shot for real surf, but even at that, pretty windy. All right, so let's drill down. What's the forecast? What's driving all this? Let's get into it. And there is some very good news in here, at least in terms of the La Nina, El Nino thing. All right, so first we're going to look at jet stream level winds. These are winds up about 30,000 feet. Those winds help support the formation of gales. When those gales form, the winds help direct the gale's track. We're looking for a trough, a dip in the jet stream. We see it right there. Notice we have a good healthy flow of, what is that, 170 knot winds pushing off Japan with this sort of split jet stream thing, but it all comes together here. The date line right there. You get what this helps do is create a eddy in the upper atmosphere and down at the ocean surface. That's the hallmark of low pressure. Of course, low pressure generates winds. Winds get traction on the ocean surface and produce seas. Seas, as they radiate away from the fetch area, eventually get groomed out and turn into swell. Swell, when it hits your beach like Hawaii or California, turns into surf. So we have a bit of a trough here on the date line. Then notice the jet heavily splits like it's been doing for a month or more now here. That between the two split flows here, southern branch, northern branch up here, you just get high pressure. Then we have the other thing that's been going on, backdoor troughs. The jet sort of tries to come together. It makes a trough just off of British Columbia, and that trough falls south. That's what's occurring right now. That is what supported the low pressure that's generating the raw swell that's hitting northern and down into central California today. It's also what's producing the weather, very strong winds up on the crest of the Sierra, winds 100 knots right now, blowing pretty hard and dumping snow and very cold temperatures in the 20s down to the teens at midday up at about 9,000 feet. So let's put this into motion. What's going to go on? And this is an interesting picture. You watch this trough. It continues building while pushing over the dateline. Notice the split point in the jet, all of a sudden starting to move off to the east. The inference is that there's energy getting injected into the jet, trying to keep it from splitting, and so it makes better traction across the Pacific. The further across the Pacific it can go, and the more energy it has in it, the better it does at producing gales and surf. And notice as we get into Wednesday, the split point now is somewhere north of Hawaii with a good trough here, likely supporting gale development. Thursday, the split starts dissolving. Notice the jet starts moving onshore across northern California on Friday. Now, we talked about this back in October. We were watching the MJO, and I know that's a bit down and deep detailed for some folks, but that is the key thing that influences the jet stream. We were able to get models of stuff that suggested somewhere in the late February timeframe a major shift in the jet stream would happen, and that appears to be what's happening. Yeah, it's a week or two later than expected. We're talking March 10th here, but you know what? We'll take it any way we can get it. Yeah, at that point in time, back in October, we had pretty much no rainfall in California. Things were dry. It's a much different picture now due to a series of backdoor troughs and the big atmospheric river event that happened around Christmas and New Year's. But we had talked and warned about a potential another AR event starting to happen in the late February, March timeframe. We're still not going to say that's happening, or if it might happen, it might be weaker than that event. But still, it looks like the jet is supposed to push onshore starting about Friday the 10th into Saturday. Now, what we really need is some sort of a trough to dig out here and a little bit more wind pushing into the jet to get some gales evolving. We're not seeing that yet, but as we get into 180 hours out, we see the jet now a little bit of it peeled off running up here through the Bering Sea. So that's stealing energy that might be in the southern branch. But it looks like with this pushing across the whole way across the Pacific consolidated, slamming into California, it seems like a weather event at least will happen for California. And with a little bit of luck, more than a week out, we'll get some troughs starting to show up here and maybe some support for gale and surf development. Looking down to the surface level wind, surface level pressure, we see a little bit of a low pressure system at maybe 990 millibars, very weak off of Washington, producing fetch up 25 to 30 knots, pushing into the California coast, generating raw, basically we'll call it wind swell, even though it has like a 13 or 14 second period, into California. We also see, well, the split in the jet somewhere out here, and you see a developing, well, looks like a gale trying to, and another gale back here trying to get organized. We'll put this into motion, see how this all plays out. So we get into Monday. Legitimate gale, 45-knot north winds developing on the dateline, aimed somewhat at Hawaii. We know there is a swell expected into Hawaii. I think it's on later on Wednesday. We see 50-knot winds as we get into Tuesday morning, close to the Hawaiian coast, continuing to build, but also pushing directly over the Hawaiian Islands on Wednesday, right as that swell's supposed to be arriving. So definitely junky, kind of messy conditions. Winds continue, but you also notice west winds north of the Hawaiian Islands later on Wednesday, aimed at the U.S. West Coast. That gale lifts off to the north as we get into Friday and starts dissipating. We're into Saturday now, and it's grading back to the west and almost gone. We really need another batch of energy to get some surf, legitimate surf, going in the North Pacific, but at least Roswell, something for Hawaii. So what's the effect of those winds on the ocean surface? Well, here's the beginning of that gale with 28, or actually it says 30.1 foot seas at 36.25 north, so that's right there, 180 west. So this would be sometime on Monday the gale starts building, seas up to 34 feet as we get into Tuesday morning, and maybe holding right around there, aimed directly and in close proximity to the Hawaiian Islands. Unfortunately, fetched from that storm, pushing right over the Hawaiian Islands as the swell hits later on Wednesday into early Thursday, and then energy from that system starting to radiate off to the east towards the U.S. West Coast, but the gale itself fading, seas from it all but gone, and as we're a week out, the Pacific goes back into a quiet mode, at least from a swell production standpoint. All right, let's look at local winds for California and Hawaii right there. As we see right here, low pressure, what is that, 992 millibars, something like that, off of the Washington-Oregon border, generating fetch at 25 to 30 knots, and 20 knot fetch pushing into California. Wind-blown mess, but trades pretty light for the Hawaiian Islands. Thank goodness the wind machine has finally settled down there. As we get in Monday, the 6th of March, lighter west wind pattern for the California coast. Sort of a weak southwest flow setting up for Hawaii. On Tuesday, west winds to northwest winds, pretty light for California. May be able to get a surf session somewhere out of this along the north and central California coast. But here come the southwest winds and the low pressure for the Hawaiian Islands, with winds building to 20 knots out of the southwest as we get near sunset. Wednesday, full-on wind machine for the Hawaiian Islands. No hope. Light northwest flow for the California coast. Thursday, lighter winds still for California. Full-on wind machine, the exact opposite of nuking trades. Now we have nuking west winds at 20 to 25 knots for the Hawaiian Islands. Nobody's getting a break this year. With the jet stream starting to move into California as we get into Friday, look at this southwest winds, 25, 30 knots along the California coast. Low pressure further off. Lighter winds for the Hawaiian Islands, but still west at like 10 knots. So we get into Saturday, lighter wind regime for California, a lighter westerly flow for the Hawaiian Islands. And then we get into Sunday, pretty much light and calm for California, and a pretty much mixed wind, but light wind pattern for the Hawaiian Islands, and then things settle down from there. Precipitation forecast, we're looking at California. We're going to be looking mainly for rain and snow. Well, on Sunday, it shows some sort of scattered showers for the whole California coast, but here in the Bay Area, it's dry, the sun's out. No need for even a coat to protect you from any rain, but certainly snowing in the Sierra. We checked. I-80 closed, I-50 chain controls, a windy, blowy mess indeed. So we get into Monday, again, this sort of mixed light shower pattern for most of California, even down in Southern California. Light snow for the Sierra. As we get into Tuesday, things dry up, except for up at Cape Mendocino, but light snow continues mainly for the Tahoe area through the day. Rain falling south into central California as we get into Wednesday morning. Light snow for Tahoe again. So we get into Thursday, everything clears up. But then here's the beginning of that jet stream enhanced moisture flow pushing into California as we get into Friday. Theoretically, snow building along the entire Sierra, rain down to Point Conception early, pushing into Southern California. Heavy snow at higher elevations of the Sierra later in the day. Rain the whole way down to, well, maybe we'll say LA County, something like that. So we get into Saturday, that system slowly starts fading. Heavy snow, though, still for the Sierra. And then we get into Sunday, a week out, a clear pattern, but another bit of precipitation lingering off the coast. We'll see how that plays out. But longer-term models suggest a steady string of storms pushing towards the California coast, driven by the jet stream. Warm, moist storms are expected. Snow forecast dashboard for Olympic Valley. Now, there is a lot of variability in this. The run before this one had none of this off-the-chart spiking stuff going on. So take all this with a grain of salt. But again, you see there is snow. The blue is the actual snow. The red is the accumulation. You see steady snow into the morning of the 8th, then a bit of a break, and then this big dump coming around the 10th, 11th, okay? And then more beyond that, with accumulations theoretically over 100 inches. That's a lot of snow on top of the, well, let's see, last week it was 76 inches, okay, and then another 2 to 3 feet forecast occurring right now, and then you dump another multiple feet on top of that, and it's just more snow than anyone would not want to deal with. Kirkwood, a little bit more moderate, but still up to theoretically 96 inches 10 days out from now. And even Mammoth in the game with probably 90 inches, something like that. Again, though, all this here, very, very unstable, we'll say, not guaranteed. The model's changing almost every run, so watch this closely. Don't book your tickets until you have to. Now going back to Olympic Valley, we're looking at snow levels, and here is where the freezing level. This is the real big teller here on what's going on. So today, the red liquid precipitation or above freezing temperatures, the gray, the area where you'd get sleet, that's like 37 degrees to 32 degrees. The white is at the start of the white line is the freeze line, 32 degrees Fahrenheit. You can see the freeze level at about 3,000 feet. This is the bottom of Olympic Valley. 6,200 feet in the parking lot there. The summit up at the top of Granite Chief and Palisades, about 9,000 feet. You see low snow levels, and then we get to the 10th. The freeze line goes the whole way up to 8,200 feet, something like that. Then it falls down. This is the typical atmospheric river sort of situation where you have a big warm front, warming temperatures, a bunch of driving rain, and then magically as the front pushes through, it all turns to snow and it starts dumping. The freezing level falls down, theoretically down to about 1,000 feet, and then theoretically another warm pulse starts building behind that with the freeze level up at about 7,000 feet. This actually looks kind of more like normal Tahoe wintertime weather versus the extremely cold events that we've been having as of late. And then the wind speed forecast. So it doesn't show it here, but winds were gusting up to 100 miles per hour, or knots, as of this morning sometime. Theoretically, that falling down, and we looked at the wind gauge a little bit ago, things settled down. But with this theoretical atmospheric river event, winds gusting again theoretically to 80 knots as we get into the 10th and the 11th. So definitely a mixed bag, variable conditions, assuming any of this even happens, but it is kind of fun to watch. And with that, let's go take a look long-term. What's going on with the MJO, the Madden Julian Oscillation, and the El Nino Southern Oscillation, ENSO. That is the La Nina El Nino Oscillation. So we first start looking for signs of the MJO, the active phase of the MJO to be specific, the Madden Julian Oscillation. There's two phases, active and inactive. The active phase is typically on one side of the planet, the inactive phase on the other. They rotate as a pair on opposite sides of the planet from west to east. The active phase is the one we're interested in. It is like a low pressure system. When it moves over the West Pacific, it imparts energy to the jet stream, forcing moist, warm air, again, being a low pressure system, it forces warm, moist air up into the atmosphere. It gets connected with the jet stream. That imparts energy to the jet. A stronger jet is more apt to produce storms, and the troughs that we talked about earlier, those troughs then, of course, produce wind, which produces surf, and also a more energetic jet will push more wind energy and moist, wet air into California, ultimately resulting in rain and snowfall at higher levels. The active phase of the MJO also has the property of dampening trade winds. Trades typically blow from east to west, This is the Pacific here, West Pacific here, East Pacific here. You just look at the arrows. That's wind speeds. Okay, you can see, and the longer the arrow, the longer the wind. So pretty strong easterly trades over the East Pacific, continuing building to strong status over the Central Pacific to the date line, then weakening some as they move into the West Pacific, what we call the Kelvin wave generation area. Because when the active phase moves over the West Pacific, it dampens trade winds, and dampened trade winds allow warm water that's typically pooled up here to start flowing east. Not on the equator, but under the equator, like a ball of warm water. It takes about 3 months to make its way across the Pacific, eventually erupting off the Galapagos and Ecuador over here. If you have successive active phases of the MJO, you can get successive Kelvin waves. That really warms up the water in the East Pacific, and that is the hallmark of El Nino. And once that gets going, well, El Nino, you know what that does. Creates large surf, sometimes raw surf, and piles of moisture moving into California. Very much like a steady, nonstop atmospheric river. It really feeds the jet stream. Notice that we have had a atmospheric river in the Christmas time frame, another one, both associated with the active phase of the MJO, another series of them theoretically forecast over the coming weeks. This is part of the transition. Also, we're getting successive Kelvin waves. We'll get into that. This is part of the transition towards El Nino that was forecasted 9 months ago. It seems to be happening pretty much right as the models projected. This is great news. All right, but it's not the wind speeds that matter. It's the anomalies, differences from normal for this time of year. Are these winds always blowing strong here, or are they a little bit stronger or a little bit weaker? Well, look at the arrows here, and they're pretty much not doing anything. So this is a typical wind flow relative to the East Pacific. Central Pacific, maybe just a little bit stronger out of the east. In the West Pacific, well, it says it here. You really want to see what's going on over here, but all the sensors on the buoys are down here. But you see, at worst, maybe just a little bit stronger out of the east than normal. Let's go look at the forecast a week out. All right, so here we go. Zonal wind anomalies, just the east-west component of the wind. Are winds blowing stronger easterly or stronger westerly than normal? The blues and the purples here, stronger easterly anomalies. Think of that as the inactive phase of the MJO. If there's multiple of these strung all together, which there have been for 3 years, that's La Nina. But also notice the oranges and the yellows here. Westerly anomalies. And notice, and let's get ourselves oriented. This is the whole planet, so the date line runs right up the middle of the chart. The far West Pacific starts about 125 east, so right there. So the Kelvin wave generation area is right here from about 170 west to as far over in the West Equatorial Pacific as you can get. California is about 120. Okay, and Ecuador's at about 80 west. You can actually see a seam in the picture right there. But it's the Kelvin wave generation area right around in here that we're interested. Now notice back in February, westerly anomalies, as predicted, right on the dime, started slowly building their way across the Pacific to the date line. They sort of held there and backed off. That was a Kelvin wave. But then look at this. Another burst of them is pushing across the Pacific, has been for the past couple of days, and the forecast is nothing but neutral to westerly anomalies. This is actually an upgrade from even a couple of days ago. Neutral to westerly anomalies, filling not only the Kelvin wave generation area, but the entire Pacific with strong westerly anomalies south of California starting a couple of days from now and going off the chart. When you get this sort of indicates where the active phase of the MJO is moving from here to here, and it moves from west to east on the equator. But when it's south of you, that's when it has the strongest effect on your local weather. So if you're in Hawaii, somewhere around March 6th to the 8th, something like that, right when that storm's supposed to be pushing north of the Hawaiian Islands, that would be probably the peak of the active phase relative to Hawaii. But now relative to California, well, it looks like starting about the 7th and going off the chart, so at least 5 days, the peak of the active phase relative to California, the highest potential for rain and wind. Let's go out 2 weeks. We're looking, this is outgoing long wave radiation, cloud cover over the entire planet. South America there, Central America, Hawaii, New Guinea there, dateline there, equator right there. The blues, This is outgoing long wave radiation. It just means cloud cover is all it is. The blues are negative anomalies, meaning more cloud cover than normal, meaning the active phase of the MJO. The reds likely meaning high pressure, zero cloud cover, the inactive phase of the MJO. So in the inactive phase of the MJO, building over the Indian Ocean into the maritime continent, active phase, solid over the Kelvin wave generation area today, okay? Looking out 5 days from now, no real change. 10 days from now, active phase of the MJO moving a little bit off to the east. Inactive phase trying to get a foothold in the West Pacific. And more of the same as you get 15 days out from now, 2 weeks. Now, this is from the statistic model. The dynamic model looking pretty much exactly the same. Strong. Now, this is interesting here. This inactive phase of the MJO, strong over the maritime continent. We have been in a La Nina pattern, which typically puts these inactive phases somewhere over the Pacific and staying there more than normal. Okay, now the pattern appears to be reversing with active phases of the MJO in the Pacific and the inactive phase setting up, drying out the maritime continent as they have been getting a lot of rainfall for the past 3 years compared to California and the Pacific Ocean. Let's dig a little deeper. Phase diagrams for the statistic model and the dynamic model here. The MJO, how do you read this chart? MJO moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. This is in January, this is where the active phase has been. The stronger these dots are, or the further these dots are away from this circle, the stronger the active phase of the MJO is. Now notice in February, it transitioned, dipped into the West Pacific, but really weak, and then has been rebuilding. Here's where it is right now, a borderline moderate to strong active phase of the MJO over the West Pacific, and we'll say even moving to the dateline. The forecast per the statistic model has it moving over the East Pacific and then over the Atlantic and somewhere near Africa, anywhere from weak to strong status 2 weeks from now. The dynamic model has the active phase getting incredibly strong while moving over the East Pacific. We saw that on the previous chart, and then over the Atlantic, and then collapsing somewhere over Africa 2 weeks from now. So the two models not too far apart. Good agreement. Something definitely is happening in the atmosphere. Yet another view of the MJO. We're talking about cloud cover. We talk about low pressure or wind anomalies. This is precipitation, moisture in the atmosphere. Greens are areas favorable for precipitation. Oranges, not favorable for precipitation. Active phase of the MJO and the inactive phase. Let's get ourselves oriented. This goes out 40 days. South America, Central America, New Guinea, dateline roughly there, equator right there. The same chart, just with the MJO moving over it. Now, this is up at upper levels, so it runs about a week ahead of what's going on at the surface. 5 days each panel. You see the active phase of the MJO, so it shows here. In reality, it's back here somewhere again, making its way into south of California and into Ecuador roughly the end of March. Add another week to that, so it'll be early part of April. The inactive phase of the MJO making its way into the West Pacific about mid-March, making its way across the Pacific, and then the active phase of the MJO, again, rebuilding over the West Pacific as we get into maybe the first week of April, something like that, and then taking over the Pacific yet again. All right, let's go look out now a month. This is from the CFS model. East-west component of the wind. The blues, the easterly anomalies. You can see the preponderance of easterly anomalies that pretty much died somewhere around mid-February. But this blue pattern centered, and here's the date line. This is the whole plan on one chart again. So the far West Pacific here, right here, about 125 east. Kelvin wave generation area ends about 170 west. That's the area we're most interested in right in here. But we'll talk in California at 120 west. So easterly anomalies continued La Nina enhanced. The dotted contour is the inactive phase of the MJO. The solid contour, the active phase of the MJO. So here's the active phase of the MJO, westerly anomalies that occurred around the Christmas time frame, made all that rain and the atmospheric river events, multiples of them that pushed into California. Inactive phase of the MJO went till about February 15th. Major active phase of the MJO in process right now over the Kelvin wave generation area, supposed to be moving east of it come about mid-March, something like that. But notice this big pile of westerly anomalies forecast building south of California, we'll say about the 8th or 9th of March, and continuing nonstop into at least mid-March, if not the 20th or 24th of March, something like that, and then continuing on the way across the Pacific. A major active phase of the MJ with major westerly anomalies forecast. If this doesn't create a Kelvin wave, I don't know what would. This would be number 3 Kelvin wave in the series. Then beyond that, the dotted contour and inactive phase, week 1, pushing into the Kelvin wave generation area the latter part of March, but not looking particularly impressive, exactly the way we want it. And then finally, the CFS model going out 3 months. This is past performance down here, forecast up here. Date line right up the middle. The yellows and oranges, westerly anomalies. The blues, easterly anomalies. This is inactive phase, or the La Nina signal, which persisted again for multiple years, died on February 15th. Westerly anomalies, first push of the MJO occurred back in mid-February. A far bigger westerly anomaly, a push going on right now. And you notice, compared to here, nothing but westerly anomalies in the Kelvin wave generation area from 125 east to about 170 west for the foreseeable future. A major change in pattern, blue to yellow, easterly anomalies to westerly anomalies. We expect a significant change in the weather pattern, and we're seeing it on the near-term models now. This has been what has been forecast for months and months. We've been hyping it up and talking about it. Somewhere starting in the late February timeframe, a change in the weather pattern. Also, we were hoping for a change in the storm pattern and surf production. We'll see whether that materializes or whether this will just be only a weather event or not even that, just a change in the MJO cycle and ENSO. So we overlay the MJO, the solid lines here, active phase of the MJO. You can see it just like in the previous chart, moving across the Kelvin wave generation area into about the 23rd, 24th of March, something like that. Inactive phase coming behind that, very weak, just a little tiny area, easterly anomalies, but mainly just neutral anomalies. Then after that fades, even though theoretically weak inactive phase or maybe high pressure in control, well, westerly anomalies just filling the Kelvin wave generation area. In fact, let's overlay the low pass filter. So this shows your tendency towards high and low pressure. Dotted contour, high pressure. The second contour, this is the clear La Nina signal that's been over the date line, pretty much dissipates. The second contour fades in less than a week. And the primary contour moves out of the Kelvin wave generation area completely as we get to April. And even better, the solid contour here is the El Nino signal, which has been locked over the maritime continent for 3+ years now. You see it's already starting to move deeper into the West Pacific. It's about 140, something like that, 145 east right now, so almost halfway into the Kelvin wave generation area, and making a stronger push as we get into, I'm just eyeballing this, about mid-April, filling the Kelvin wave generation area and pushing even further east from there. If this isn't a setup for El Nino, don't know what is. And this bodes very well. This model ends in June, but this bodes very well for what's going to happen for the Pacific as we get into next fall and next winter. If we're wet now and we're moving into an El Nino pattern, one would theoretically think we'd be wet next winter. And then even if El Nino dies the year after that, still that transition from El Nino to La Nina, there's a lot of wet air in the upper atmosphere, that will continue to fuel backdoor troughs and precipitation in California the year after that. So theoretically, and this is quite a reach, of course, just rampant speculation, but we think we have 3 years of wetness for California in flow, part of it being this year. Next year, the El Nino signal, and then maybe the transition out the year after that. Or maybe it'll be a false start El Nino, and it'll go for yet another year beyond that. Too early to know, but fun to watch and fun to guess. All right, so what's going on down in the ocean? We've talked about Kelvin waves. Are they in flight? Where's warm water? Where's the cold water? How's this all work? This is data from the TAO buoy array series of buoys strung across the equator used for monitoring El Nino. These lines here, these X's, these are the anchor lines on the buoys strung the whole way across the equatorial Pacific from Ecuador to Japan. Of course, part of it is out over here, but the X's are actual sensors on those anchor lines. They collect data, use the model to fill in the gaps, and you get a profile of what subsurface water temperatures look like. The 29 degree, that's 29 degree Fahrenheit, very warm water, is just starting to show on the picture here. The assumption is it's all filling in back here. The 28 degree isotherm is right here. It was back at 170 east 2 weeks ago, about 175 east a week ago, and maybe moving another degree or so to 176, maybe even 177 east, suggesting warm water is slowly pushing off to the east. Now, even better yet, the 26 degree isotherm for years was stuck at somewhere around 155 to 160, fully flowing into the East Pacific with 27 degree temperatures at the surface, suggesting maybe Kelvin waves have already erupted and are starting to build that signature warm water water temperature slick off the Ecuador and the Galapagos. Okay, and then the 24 degree isotherm, which was stubbed off around 120 a year ago, and cold water was here, now getting deeper and deeper as more warm water builds into the East Pacific. Now, that's the actual temperatures. The anomalies really tells the picture. What is this? How is this different from normal for this time of year? Well, massive pool of warm water building in the West Pacific, 4 degrees centigrade above normal. Okay, Kelvin waves typically flow west-east from this area down about 150 meters, that'd be right here, across the Pacific, and then they start warming as they push up the thermocline off of Ecuador. We see what looks like at least one Kelvin wave that's erupted here, pool of warm water. A second Kelvin wave we know is in flight, and yet more warm water waiting for another active phase with its west anomalies to start blowing here, taking that warm water, pushing it down to depth, and then it takes the 3-month trip across the Pacific to reach Ecuador. We are in business. Another view of that, but instead of using buoys, this uses satellite data to measure the height of the ocean surface. And if it's higher than normal, that assumes warm water at depth. Colder than normal assumes cold water at depth. And you see basically the same thing. Big old pile of warm water here. But even more interesting, look at this little finger here. We think that is from the current active phase of the MJO, blowing westerly anomalies, creating backup of warm water, starting to build in the far West Pacific. We also see right there, sure looks like a Kelvin wave if there was one. It's moving to about, what is that, about, just eyeballing it, about 110 west. And we've been watching this warm water pool slowly, it's like watching grass grow or something, slowly work its way off to the east. Remnants of a previous Kelvin wave off of Ecuador, the last of the La Nina cool pool sitting here off of Ecuador and all but gone. There's a bulldozer of warm water heading off to the east. It doesn't stand a chance. A significant change in the weather pattern is setting up. Sea level anomalies. This is the satellite data we were talking about. Satellite makes polar orbit around the planet. It strips out, it reads using radar, reads the height of the ocean surface. Take out the waves, take out the tide, take out wind waves, and is the sphere of the ocean higher or lower than normal? If it's higher than normal, that assumes warm water at depth expands, creates a bump on the ocean surface. Cold water at depth contracts, will create a divot on the ocean surface. Let's get ourselves oriented here. So we have Chile, Peru, Ecuador, the Galapagos Islands, that little squiggle right there, Central America, Hawaii right there, equator, dateline, New Guinea right there. Look at all the positive, 20, 25, 30 centimeter anomalies all in this area. Very warm water. We see a finger of those positive anomalies pushing across the equator. Another pocket here somewhere south of California. Another pocket building off the Galapagos. The last of the little cool pool right here along Ecuador. Sure looks like a flood of warm water is pushing from west to east. Multiple Kelvin waves interacting with one another, slowly building a river. Now, this is all subsurface. This isn't the ocean surface. This is down at depth, down 150 meters. But you can't see it yet. But the thought is the fire hose has been turned on and piles of warm water are flowing off to the east under the equator. Upper ocean heat anomalies. This just gives you sort of a time, a past look at what's been going on. West Pacific here, East Pacific here, blue colder than normal temperatures, red warmer than normal temperatures. You just look down here and you see, well, it's pretty warm in the West Pacific. You're just getting warmer and warmer and warmer. The far West Pacific in this case is at 130 east, driven by westerly anomalies, scooping warm water over the maritime continent, flooding it into the far West Pacific, and then if the active phase continues pushing off to the east, it creates, well, like a Kelvin wave here. There's a Kelvin wave here, but these are just random Kelvin waves, and notice there was piles of cold water at depth. This is back March of last year. A massive cool upwelling event in July, August, September, all fall. Little bit of a Kelvin wave from the December active phase of the MJO made it across the Pacific, punched a hole in this cold water. That's all it did. Another one in January, you see, trying to make its way across. We think there's yet another one developing right here associated with this active phase of the MJO has only been in effect the past week or two. We think it's already starting to show signs of creating a Kelvin wave. The Kelvin wave from the previous active phase of the MJO is at 115 west today, so it's even past California, heading towards the Galapagos. At some point, there's going to be a big eruption. You'll see these yellows just start building and filling this whole area, but we're probably 2 months out from that starting to happen. Sea surface temperature anomalies, difference from normal for this time of year. Chile, Peru, Ecuador here, the Galapagos, up into Central America. What really matters is pretty much 5 degrees north and south of the equator. You can see warming off of Chile, Peru, Ecuador, the Galapagos here, and notice warm water building the whole way out to 140 west, roughly. This is the beginning of what we think the images don't quite overlap here, but you get the general idea. Warm water building on the equator, no more cool water in effect. Now, contrast that with so this is the beginning of El Nino here. The remnants of La Nina, you can see it clearly off of California. If you had high pressure here, it circulates clockwise. Springtime, the high pressure gets really amplified. You get all this upwelling along the California coast. Sea surface temperatures are like 49 degrees, very cold off of San Francisco right now. And even as you get down around Point Conception into Southern California, temperatures much below normal for this time of year. This is La Nina's last stand, isolated to the East Pacific. All the while, El Nino's first toe in the door is starting to show up off of the Galapagos. So an interesting picture here. What was and has been in place for 3 years, and what is coming for the future 2, maybe 3 years, if we're lucky. Sea surface temperature trend for the past 7 days. So things had kind of mellowed out here a couple of days ago, but here we go again. warming temperatures all setting up here off of Ecuador, the Galapagos, off of Central America, on the equator, the whole way out to almost the dateline, and warming still occurring off of Peru and somewhere around Tahiti. This is the last bit of the La Nina cool pool slowly getting crushed. And you can see it here. Here's the warming temperatures. Here's actual sea surface temperature anomalies, warming building in this area off Peru. Here's the last little bit of La Nina right here, just 5 degrees north and south of the equator. And this cool pocket, which has sat here down in the southeast Pacific for years now, looks like it's finally really getting just crushed out. And off north of Tahiti in this area, we want to see all this coolness even down this far south to disappear. And the expectation is we're going to see a building warm water pattern in this area, not in the next week or two, but in the next couple of months, the beginning of El Nino. Sea surface temperature anomaly in the Nino 1.2 region. So this is the area right off of Ecuador and the Galapagos and maybe the north part of Peru. You see temperatures steadily warming. Oh, this is 0. That's neutral. Okay, anyway, if you're anywhere from a half a degree to a half a degree below to half a degree above normal, that's kind of considered neutral. We were clearly in a La Nina signal down at like almost 1.5 degrees for years. Look at this, up to +1 degree, even up to +1 degree for a day or two, 1.2 degree, and about half a degree, actually 536 thousandths of a degree today. Now that was not the official El Nino monitoring region. The Nino 3.4 is the official El Nino monitoring region. The region from on the equator south of California out to about the dateline. Again, there's your half a degree. This is the neutral, the beginning of the neutral range. We popped into there, let's see, that's 19th of 2021. On the 22nd of February, we popped into the neutral territory range, and we're slowly building from there. We're at 386 thousandths of a degree below normal. We're still not even at 0, but the trend is finally, after forever, at least moving in the right direction. So what does the atmosphere think is going on? Well, if you have cold water on the equator, that typically supports high pressure development up in the atmosphere above it. Cold water doesn't allow for evaporation. You don't get any clouds. You get bulletproof high pressure. Warm water on the ocean surface creates more evaporation, lifting air. That supports cloud development, low pressure development, and that's what we want to see. So this is the difference in pressure between Darwin, Australia, and Tahiti. It's called the Southern Oscillation Index. Darwin in the Indian Ocean, Tahiti over, well, we'll call it the Central South Pacific. When the integration of these two numbers suggests that lower pressure is over Tahiti, the index goes negative, minus 4.55 today. That's not particularly negative. It's pretty much neutral. It was neutral yesterday, but that is really good compared to where we've been for years now. Looking back in time, well, a month ago, we were at almost 20, plus 20. Now we've got these little pockets of negatives and generally averaged lower readings, negative today, suggesting that pressure is starting to drop in Tahiti. Tahiti isn't in the far west Pacific. It's like at 140 west. It's further east than Hawaii. So this suggests, in general, we think low pressure is getting more of a toehold, or at least the active phase of the MJO, which is a low pressure system, is getting more of a foothold in the West Pacific. 30-day average, just take 30 days of these numbers, average them all together. The value today, plus 9.11. We want to be at least at 0. We're still positive, but where were we? Oh, a month ago? Well, at 10, pushing up to 14, and now starting to trickle back down. The 90-day average, still well positive, 12.91, right? But where were we a month ago? Well, 12.56. So still holding more or less, it looks like in a La Nina position. In fact, let's go graph this out. So here's the 30-day moving SOI graphed out today. Well, this shows it right about 10. This is a little bit different data source than what we looked at before, but still you can see the trend. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase of the MJO. You draw an average line through that, and you see this is the La Nina signal going from 0 back in January 2021, steadily pushing upward till July 2022, sort of hanging there. Now heading down, another active phase of the MJO moving towards Tahiti. We think this is going to continue to fall, and we're hoping reaching at least 0 somewhere in the next 2 months, something like that. Right now, it doesn't look like much of a trend, but we think this inactive phase of the MJO, because it didn't really spike up, and because we're just hovering around here, and we know the active phase is coming, we expect this to continue falling. This will be the last indicator, really. Sea surface temperatures are already warming. This is like a lagging indicator if there is one, but when you see this guy falling, that clearly gives you an indication something's changing in the Pacific. We're not quite there yet, but all the early warning signs are flashing red. And finally, the sea surface temperature forecast for the official El Nino monitoring region, the Nino 3.4 region, south of California out to the dateline. Sea surface temperature anomaly forecast, we're just going right to the PDF corrected version. Supposedly, sea surface temperatures, well, they're steadily, you can see them trending upwards since November. And forecast, the dotted line is the forecast, hitting normal as we get into the latter part of March. So we're only 3 weeks, maybe not even that away from this happening, hitting neutral, and then moving into the half a degree above normal. That would be the El Nino minimum threshold as we get into late June, early July, and then moving from there up to 1 degree above normal as we get to the beginning of fall. We're really looking forward to what's going to be happening when we get there. So for right now, things looking pretty interesting. The Jetstream consolidating as forecast, and theoretically going to push the whole way across the Pacific and into California within the next week, and then theoretically holding in that position maybe for a couple of weeks past that. Now, this isn't great for surf production. It'll probably be a pretty stormy mess in California. And we already have a lot of snow in the mountains, and it might raise temperatures, and that might create some issues, and it might dump a whole lot of rainfall on California. Still, very much unknown. The model's not, they're kind of waffling all over the place. But we seem to think that it's likely a lot of precipitation is probably headed for California as the active phase pushes south of California. Good for filling up the reservoirs right to the top and then some, and then filling up the delta with yet more water. We'll take it. We've been in a drought for a lot of years. Every drop counts. The aquifer well depleted in the Central Valley. You need that for the farming community. So we'll take any bit of water we can get. Surf-wise, yeah, raw swell for Hawaii on Wednesday, and then things fading out. We're really kind of hoping we'll get some more storms on the chart as the energy gets imparted into the jet stream. The jet stream gets its act together over the next 2 to 3 weeks, but the jury's out on that. We're clearly moving into a springtime pattern, so there is a bit of high pressure and upwelling along the California coast, so jury's out on that. But either way, the transition that we had talked about for months, it's happening. The Pacific, La Nina is dying, and it appears like we're moving into at least a neutral pattern, if not a building El Nino pattern, as we get deeper into the summer. What's happening right now, though, is all the classic first signs of a building El Nino. It's fun to watch it happen in real time. We've got so much better graphics and data and forecasting now than we had even in the last El Nino or the El Ninos before that. It's great to be able to share it with you all and to have everyone go along for the ride and watch it together. And also, special thanks for the super thanks. If you can make a donation, that's great. Not required. sooner, but we would appreciate it. All right, otherwise, give us a thumbs up or a like. This is the end of the video for this week. Yeah, I know we ran long. We're going to try to do it next week. If we're not chasing snow or surf or something, we'll just leave that open. But if we don't do it, then we'll try to make it up at another date. All right, thanks for watching. And for now, we'll see you again next week. Same time, same channel. Stay safe. See ya.